So we're going to finish up the review for the final exam looking at relations and functions. What do you need to know? What's important from relations and functions? First thing that I want you to star, domain and range. We did a few worksheets on domain and range. You need to grab those worksheets and look at a few examples. Not only is it going to be on your exam, remember it's a huge topic in 20-1 and 30-1. So we'll do the domain of this graph, and then I'll talk about a couple other graphs. We'll do both domain and range. So remember that domain is your x values. If you are asked to find the domain of a given graph, you say to yourself, what is the biggest and what is the smallest x value? This graph here, it does not stop at the end of the grid because there's no solid circle here. So what you have to imagine is you have to imagine that this graph will continue forever in that direction and forever in this direction. If I say to you, what's the biggest x value? It's infinity. It'll keep going and going to infinity. The smallest x value is negative infinity. If ever you have a negative infinity to infinity, that is an XER. So what the domain of this function would be is your fancy bracket. X is such that x belongs to the element of the real numbers, and you close that bracket. I showed you interval notation. I'm just going to quickly show you interval notation. Even though interval notation is not big in 10C, you could use it in 20-1, and then it's almost all you'll use in 30-1. Remember, interval notation had two brackets, and you put the smallest number on the right, the biggest on, sorry, smallest on the left, biggest on the right, and then a comma in between. So the smallest for the domain would be negative infinity, and the biggest would be infinity. Infinity always gets rounded brackets. You'll never put infinity with a square bracket. That's the domain of that function, so XER. Once we get to the range, range is a set of y values. So you ask yourself, what is the biggest or the smallest y value on this graph? The biggest y value would be 6. You then need to say, so it's the biggest y value is going to be 6. That's the biggest. What's the smallest y value? Well, it's going to keep going down to negative infinity. So if you have, remember, a number and then an infinity, you have to take that number and you have to say either y is greater than or equal to 6 or y is less than or equal to 6. So it wants to know this line here, which is at 6, is my graph below or above? Is it less than or greater than? And this would be what? Less than. So how you would write the less than would be as follows. The range of that function is y is such that y is less than or equal to 6, comma, yer. If you were to do that in interval notation, you'd have your smallest and your biggest. Your smallest is going to be negative infinity, so that would get a rounded bracket. Your biggest is 6, and because it could be equal to 6, we put that square bracket. Okay. What you really want to review when you're looking at domain and range is the shapes. Okay, the triangle, a circle, the oval. Can you do the domain and range of a shape? So you get your worksheet, look at those ones, make sure you're good with shapes. Okay, so that's domain and range. Let's move on to nothing on discrete data versus continuous, right? So you don't have to remember discrete is dots, continuous is a continual line. And this is just on not, if there's anything on interpreting data, you'll be okay with those types of questions. Let's go down to functions. So on your next page, you have functions. We were given a set of graphs and you were asked, is the following graph a function or not? In order to tell if something was a function, we performed the vertical line test. So any graph that I give you, if you're asked if it's a function, you perform the vertical line test. With these two graphs here, you would draw a vertical line. If your graph cuts through the vertical line at more than 1 point, so in this second graph, it cuts through at more than 1 point, this graph fails the vertical line test. Therefore, this graph is not a function. And I'm just going to shorthand function by writing f of x. It's not a function. It's a relation, right? This one here, no matter where you draw the vertical line, it would pass the vertical line test. So this graph is the function. So passes VLT, and it is the function. I'm going to show you how, if I give you a set of coordinates, how you could just look at the coordinates and say if it's not a function or if it is a function. So going to this example here, if I gave you these two coordinates, it would be x is 3 and y is 2. So I'm going to write just up here. So if they give you a list of coordinates, so say 3, 2, say they give this coordinate here, which is -1, 0. Let's say they give this coordinate here, which is 0, comma 1, and then they give that coordinate down here, which is 3, comma -2. If you are just given coordinates and not a graph, and they say based on these coordinates, is a graph going to be a function or not? Which value are you looking at, the x's or the y's? The x's. So what you do if you're given a set of coordinates is you say you can only have one x for every y. So you just have to scan the x's and you cannot have an x repeating itself. If you have an x repeating itself, you're going to have this scenario and it's not going to be a function. Okay, so that is functions. You don't have to worry about mapping. You know about ordered pairs. We're going to star number 19. You need to be able to do solving f of x questions. So I will do h with you, and then when you're studying, you could do I and j if you want. When you are given f of x is equal to, this is going to give you an ordered pair on your graph. This is the x coordinate on the graph, and whatever value you get with the function, that's going to be your y value. So it's always going to give you an ordered pair on your graph at x comma y. So if I say calculate f of -9, that is replacing the x, right? -9 goes in here. So if it's replacing the x, that means this x comes out, and every time you see an x, you're going to put a -9 in. So 4 times -9 minus 5. F of -9 is equal to, then you'll evaluate 4 times -9, which is -36, and that minus 5 is going to be -41. So what that means, again, this is a point on this graph, and the point would be, that's the x coordinate at -9, and this would be your corresponding y coordinate at -41. The other way that you need to be able to deal with functions and with the algebraically showing functions is if I said this. Let me just quickly look at what the number would be. 3. Okay, so let's say I said f of x is equal to 3. And it's for this exact same formula here. What did I just give you? F of x is equal to 3. That's the y value. So this here, that's the y value. So x comma 3, we need to figure out what the x value is. So if this was the graph here, you need to take f of x out, right, because that's really y. So f of x comes out, and 3 goes in. 3 is equal to 4x minus 5. And then you need to isolate to get x. You need to say, okay, I need to get this 4x by itself. How do you get rid of that negative 5? You're going to add 5 to both sides. That would give you 8 is equal to 4x. What would x be equal to? X would be equal to 2. The last way you need to be able to read functions like this is as follows. So let me just get rid of that. I'm just going to use this grid to draw a different graph. Okay, so the graph that I'm going to draw will be this. So you don't have to worry about drawing this. You could just sort of look and see if you were able to answer these questions. If I give you a graph and I say, what is f of 1? Do you remember how we did this? If I say, what is f of 1, this is which coordinate, x or y? That's x. When x is equal to 1, here's where x is 1. What is the corresponding y value on the graph? So when x is 1, you'd go up to the graph, which is right here. That's where x is 1. What's the corresponding y value? 4. So f of 1 is equal to 4. You also have to be able to work the opposite way. So for example, I could ask this. F of x is equal to 2. If I give you that and you only have a graph to work off of, I have just given you the y value. So it's going to be something, comma 2. So you go to where is y2? So on the graph, here's where y is 2 on my grid. Then you go to your graph. That's where the y value is 2. And what is the corresponding x value? Negative 1. Right? So if I give you f of x is equal to 2, the answer would be x is equal to negative 1. And then I remember I gave you a worksheet on this. So you could, if you need extra practice, you could look at extra practice on that. Okay, let's now go through the 3 equations of the line and slope of a line. Remember that if you go up the hill, that's going to be a positive slope. If you go down, it's going to be negative. And the ground has a slope of 0. The formula for slope, which will be given on your formula sheet, is m is equal to y2 minus y1 over x2 minus x1. Okay, so that's going to be the formula for slope. You need 2 points. What we're going to do is we could, for this slope here, we're going to count rise over run, but chances are on a test, I wouldn't give you the actual graph, I would just give you 2 points. So let's figure out what the slope is by doing rise over run, and then we'll use the formula. So the rise is 1, 2, 3, a rise of 4. And the run is 3, 4 over 3. Let's now use the actual coordinates and enter them into our formula and see if we get 4 over 3. One of your points pick as x1, y1. So I'm just going to pick this first one down here, x1, y1. The other point would therefore have to be x2, y2. You enter it exactly as you see it. So slope is equal to y2, which is 2, minus y1, negative 2. 2 minus negative 2 over x2 is 3 minus x1 is 0. 2 negatives will give you a positive. So the slope is going to be 4 over 3. what if I said, what is a perpendicular slope to 4 over 3? Raise your hand if you remember that. Here's a symbol for perpendicular. It's like an upside down T. So Ainsley, Maria, what would it be, Maria? Sorry? Negative 3 over 4. Yes, perpendicular. You take the reciprocal, which would be 3 over 4. And they're what's called negative inverses. So one always has to be positive, the other always has to be negative. So if this was a positive slope, that would have to be a negative slope. Yes. So make sure you could calculate slope. Make sure you know how to figure out what a perpendicular slope would be. Parallel, remember, it's going to be the exact same slope. Okay, if I said, what's the equation of this line? So the equation of a line, the easiest is going to be y is equal to mx plus b. M is your slope. That is your slope, which is 4 over 3. So y is equal to 4 over 3x plus, Angel, what was the b value? Y-intercept. This graph had a y-intercept at negative 2. Plus negative 2, that would be the same thing as minus 2. So I'm just going to do 4 over 3x minus 2. That is the equation of this line in slope y-intercept form. If I said change this to general, so general, the three equations again will be on your formula sheet. Here's the equation for general, ax plus by plus c equals 0. If I said to get this to general, you have to do two things. Can't have any fractions, and x has to be positive. So the first thing I'm going to do is I'm going to get rid of this 3. How do you get rid of the 3? It's being divided by 3. I'm going to multiply both sides of this equation by 3. I would then get 3y is equal to, distribute in that 3, and you would get, if you multiplied 3 times 4/3 in a bracket, you'd get 4. So 4x, the fraction would go. 3 times negative 2 is negative 6. Does everything go to the left or everything go to the right? You look at your x. Your x is the one that tells you if you move or not. That's right. The x is positive, it stays. So you're going to get this 3y over here. How you get the 3y over there is by subtracting by 3y. And what you would have in your formula as a general solution would be 4x minus 3y minus 6, and that was equal to 0. So that's figuring out your formula in slope y-intercept. This is in general. There's one more equation of the line that we will go through. And that's going to be this one here. If I said, what is the equation of this line? Most students want to default to this because this is the easiest formula, y is equal to mx plus b. But in order to do y is equal to mx plus b, you cannot have a y-intercept that's a decimal, right? This would give you a decimal. I'd be able to figure out the slope. The slope is going to be rise of 1, 2, 3, run of 1, 2, 3, 4. So slope's going to be the same. Slope is going to be 3 over 4. But I cannot use this form here because I do not know what that y-intercept is. That means I must use slope point form. Y minus y1 is equal to the slope x minus x1. You're always going to be given a point, so I'm just going to pick this one. We were actually given 2 points. Pick either. This coordinate is at 3, 1. The 3 is your x1. and the y, or sorry, the 1 is your y1. So let's fill that into our equation, and we know that the slope is going to be 3 over 4. So y minus y1 is 1 is equal to the slope, open bracket, x minus x1, and that would be 3. Okay, we need to get rid of, we need to get rid of the bracket by distributing that 3 over 4x in. And you would get y minus 1 is equal to 3x over 4. If you, again, typed in like 3 over 4 in a bracket times 3, that's going to be 9 over 4. Okay. If the question was get into slope y-intercept was that y is equal to mx plus b, right? If the question was that, you would simply, we need to isolate this y, so you add 1, right? So if it was slope y-intercept, this is what you'd be doing. And you would have y is equal to 3x over 4, and then negative 9 over 4 plus 1. As a fraction would be negative 5 over 4. That would be your answer in slope y-intercept, right? So look at our y-intercept is a decimal. This is a decimal. It's negative 1.25. That's my y-intercept. If they said from here, go to general, you say, okay, I got to get rid of those divide by 4, right? So to go into general now, multiply this side by 4, multiply that side by 4. You would have 4y is equal to 4 times 3 over 4 is 3x minus 5. You would have that. And then from here, general, Evan, do you want me to go left or right? Right. That 3 is positive, keep it there. So subtract 4y from both sides, and you'll get a final answer of 3x minus 4y minus 5. That is the answer in general. Those are the 3 equations of your line. Another thing I want to review is, do you remember how to find x-intercept and y-intercept algebraically? So if I said, here's your equation, what is the x-intercept of that graph? What equals 0? Yes. Let y equal 0. So that's your y. If that becomes 0, negative 2 times 0 is 0, so I'm just going to get rid of that. I would be left with 3x minus 16 is equal to 0, and I need to solve for x. Add 16 to both sides and divide by 3. The x-intercept is 16 over 3. Or as an ordered pair, it would be 16 over 3, comma 0. If we were then to find the y-intercept, you do that exact same thing, except you let the other variable equal 0. So if we're finding y-intercept, let x equal 0. So there's your x. That becomes 0. 3 times 0 is 0. Disappears. We're going to have negative 2y minus 16 equals 0. Add 16 to both sides. And then divide by negative 2, because it's negative 2 times y. So you divide both sides by negative 2, and you would be left with y is equal to negative 8. that as an ordered pair. If that's your y-intercept, x is 0, y is negative 8. Everybody's good with that? We're done. Okay, the last thing is on systems of equations. We are going to review this. Systems of equations, you're always going to be given two systems, two different equations. The solution is always the intersect. You for sure always get, I find on exams, a question that it'll already have each system y is equal to, so they make it nice and easy, and it says solve. When it says solve, they want the x coordinate. Chances are it's going to be a fraction or decimal, so a question like this would say solve to the nearest tenth. So let's review on our calculators how we would get the solution to this. So you take out your calculators, go to y is equal to. I get to enter it exactly as is because it's already solved for y. So the first system is going to be 2x plus 5. Second system is going to be 9x minus 3. So enter that into y2. Just in case you changed your window or adjusted your window, remember if you ever want to get back to a 10 by 10, that's going to be a zoom 6. The solutions where the two systems intersect, which would be right here. Second, the trace button, and you were looking for the intersection, which is number 5. You bring your cursor close to the intersect. You could bring it right over top if you want, but as long as it's close, right? Even if I'm here, you hit enter 3 times slowly. So enter, 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 and it will jump to this solution. If the question was, what's the solution to the nearest tenth, it would be x is equal to 1.1. If it was, what's the solution to the nearest hundredth, x is equal to 1.14. If it was, what is the ordered pair, 1.1 comma 7.3. So I'm just going to write x is equal to 1.14. Let's pretend they asked to the nearest hundredth. So x is equal to 1.14. Okay, so that's the solution to that system. Let's look at this system here. Okay, let's review how to solve this by elimination. Remember, for elimination, x's are lined up, y's are lined up, equals are lined up, and your constants are lined up. Let's say I wanted to eliminate the x's. What would I multiply this first system by? 2. If I wanted to eliminate the y's, what would I multiply this second system by? 4. Let's eliminate the x's. So if I've got 4x here, let's multiply that guy by 2x, so that we're going to get 4x and 4x. So remember, when you distribute in the 2, it goes to everything in that system. So that would be 4x minus 8y equals 14. The second system had 4x plus 1y equals 5. I am eliminating those x's, so I need to subtract. 4 minus 4 will get rid of the x's. You have to be careful with the y's. It is negative 8 minus 1. What would that be? It is negative 9. That is negative 9y is equal to 14 minus 5 is 9. Isolate y by dividing both sides by negative 9. And the y value of the solution is going to be negative 1. 9 divided by negative 9 is negative 1. In order to get your x value, you take this y And it doesn't matter which system you plug it in. You could plug it into system 1 or you could plug it into system 2. It does not matter. So I'm going to plug it in here. I'll put -1 in there. So that's 2x minus 4. I'm going to put that -1 in. That's equal to 7. 2x, -4 times -1 is plus 4 equals 7. Subtract 4 from both sides. 2x is equal to 3. Solve for x by dividing by 2. X is equal to 3 over 2. So the solution to that system, those two lines intersected at 3 over 2, so when x is 1.5 and when y is -1. Those are when the two systems intersected. If I said solve by substitution, we won't, we'll just talk about it. If I said solve by substitution, there's one of these systems that you could solve for one of the variables in one move. Which system is it and which variable is it? Raise your hand if you know. So like Ainsley knows, Shaywa knows, Angel. Shaywa, which one is it? Second system, what's the variable? The y. I could get this y by itself in one move. How I would do that is I'd minus 4x minus 4x. I have now y is equal to 5 minus 4x. I could take that 5 minus 4x and I could plug it into here. So you could practice that after. You'd be solving by substitution and you would get the exact same answer. I think there's just a couple, there's not much to practice for the homework on here. Elimination we've already done. Do you remember how to do this? If you have a 3 and a 5, we won't solve it, we'll just talk what would we multiply to get elimination. Let's say I want to eliminate the x's. What would it be? That's right. So multiply the top system by 5, and you're going to get 15 x's. And you would multiply the bottom system by 3, and you'd get 15 x's. So you could try that one. You could, when you're doing your work, try to do that one by elimination. Read this, so give that a read over. Remember that when you have systems, you have actually 3 different cases. If the lines intersect, how many solutions is that? One solution. Okay, so that's when the slopes are different. You've got one solution. If you have parallel lines, how many solutions? 0. They're never going to intersect. You're not going to get a solution. Parallel lines, remember, is the exact same slope. Same slope, but different different y-intercepts. They're going to be parallel. The last case will be if you have 2 different systems, and when you graph them, that's, let's say, the graph for the first system, and the second system goes right over top. How many solutions would that have? Infinite. Yeah, that would have infinite solutions. What's that? Okay, so circle number 2, do that one by substitution. The easiest, I actually wouldn't solve for the y here because you're going to have a negative y. So you know what I'd probably do? I'd probably, in the first system, solve for x, and I'd go minus y, and then to get rid of that -1, I'd add 1, add 1. So I am doing 2 different things, but then I get x is equal to negative y plus 1. I could then take that and put it into there. Some students will see for this system, if you wanted to use this one, add y to the side and subtract 11. And then you get y is equal to, you always want your variable to be positive. Circle number 3, that's a nice easy one to do. And then you'll just look in your book for other examples of that. And that's basically what you need to know for relations and functions.